Hello everyone, welcome back to my YouTube channel. Today I'm going to explain you about dynamic programming, a powerful way to solve problems in programming efficiently. Let's start it. First of all, let's learn what is dynamic programming. It is a method to solve problems by breaking them into small sub-problems. The key idea is to store the results of these smaller problems so we don't have to solve the same problem again and again. Okay, let's discuss why we use dynamic programming. The first point is to avoid repeated calculations. That means dynamic programming minimizes work by reusing previous calculations. Our second point is improve efficiency. That means solutions are calculated faster using fewer resources. Our third point is optimization techniques. That means dynamic programming helps in finding the best solution efficiently. Better problem solving. Dynamic programming transforms complex issues into manageable sub-problems. Concepts of dynamic programming. Basically, there are two types. The first one is overlapping subproblems. The second one is optimal substructure. Overlapping subproblems means big problems can be solved using smaller solved parts. Optimal substructure means the same small problems are solved many times. Okay, let's discuss overlapping subproblems. A problem has optimal substructure if the big problem can be solved using the solutions of smaller parts. For an example, in Fibonacci, to find the fifth number, we just add the third and fourth numbers together. Okay, let's move to the optimal substructure. Optimal substructure means the best solution of a big problem comes from the best solution of the smaller problems. For an example, Fibonacci 5 equals Fibonacci 4 plus Fibonacci 3. If we already know Fibonacci 3 and 4, we can easily get Fibonacci 5 without recalculating everything again and again. Recursion versus dynamic programming. Normal recursion often recalculate the same subproblems again and again, which is slow. In dynamic programming, on the other hand, remember the results of subproblems. This makes dynamic program faster and more efficient than normal recursions. Let's move to a Fibonacci example using recursion. In here you can see int fib inside curly brackets int n. This defines a function called fib that gives the nth Fibonacci number. And after that we can see there is an if condition. If n is smaller than or equals to 1, return n. This is the base case. If n is 0, it returns 0. If n is 1, it returns 1. These are the first two Fibonacci numbers. Returned fib n minus 1 plus fib n minus 2. This is the recursive part. It calls the function itself to find the previous two Fibonacci numbers. That means n minus 1 and n minus 2. And then add them together. This follows the Fibonacci rule. That means current equals previous plus 1 before previous. I hope you understand the Fibonacci example. Let's move to the other problems that can be solved by dynamic programming. Dynamic programming is not just for Fibonacci. It can solve many problems. Identify subproblems. Break down a problem into smaller, manageable parts. And it check substructure. Ensure optimal solutions can be built from subproblems. And then it chooses approach. Decide between memoization and tabularization for storage. Implement solution. Fill in the table or cache results methodically. Let's recall what we have learned today. What is dynamic programming? Dynamic programming means solve problems by breaking them into smaller parts and remembering results to avoid repeating work. Why we use it? Makes solving problems faster and easier. The main two parts are overlapping subproblems and optimal substructure. Overlapping subproblems means same small problems happens again and again. Optimal substructure means big problems best solution comes from the small problems best solutions. The dynamic programming is faster than normal recursion. For an example, Fibonacci sequence shows repeated work is avoided with dynamic programming. Thank you for watching my video. I hope now you can understand the basics of dynamic programming. If you like this video, don't forget to like, comment and subscribe for more programming tutorials.